In this video, we'll focus on writing equations of lines, but focusing on parallel and perpendicular lines. So if you watched the last video on this topic, we talked about the point-slope form, and we said that we could use that formula when the slope of the line that we want to write the equation for is defined. That equation uses any point on the line and the slope. If we have that form, then we'll go ahead and write our equation in slope-intercept form in y equals mx plus b form. We looked at these three examples in the last video as well, but in this one we're going to focus on parallel and perpendicular lines. So let's start with the definition of parallel lines. So parallel lines are lines in the same plane that never intersect each other. You have an image, an example of two parallel lines on the screen here. So they go in the same direction. If we extended the plane and extended those lines as far as we can imagine, they will never ever touch each other. So since the slope is what determines the direction and the steepness of the line, parallel lines must have the same slope, because if one is a little more tilted than the other, eventually they're going to run into each other, but they won't if they're parallel. The symbol for perpendicular lines you see down below here, we have L1, that stands for line 1, is, that should say parallel. So ignore the fact that this is perpendicular. That is not the symbol for perpendicular. Parallel lines. Parallel lines are looks like two parallel lines. Now, I put this example here because in our definition, to use the point-slope formula, we have to know the slope, but there are lines that have undefined slopes, and those lines are vertical. So even though vertical lines have undefined slopes, they're still parallel to each other, but we can't say they have I guess we can say they have the same slope, right? They have the same undefined slope. So all vertical lines are parallel to each other, their slope is undefined, but they never intersect. Now, perpendicular lines are lines that cross, but cross at a very specific angle. So perpendicular lines will cross at a right angle. So you have an example of two perpendicular lines here, and the equations for them are given as well. Now, perpendicular lines have a relationship between their slope. Obviously, their slopes are not the same because they meet, but their slopes do have another special relationship. In the example you see here, the line that is going decreasing has a slope of -4, and the increasing line has a slope of +1/4. So that'll always be true of any perpendicular lines when we're not looking at the horizontal and vertical case. One of the lines will have a positive slope and one of them will have a negative slope. What's not so obvious is that the slopes are also reciprocals of one another. So if you see 4 and 1/4, they're reciprocals of one another. So the relationship between these slopes of a set of perpendicular lines is that the slopes are what we call negative reciprocals. So they're opposite in sign, and one is flipped if you write them in fraction form. The symbol for, I messed that up again, I switched these. The symbol for a perpendicular line, so that should say perpendicular, not parallel. Perpendicular lines looks like an upside down T, which is kind of just a symbol of two lines that are perpendicular to each other. So two lines that are perpendicular, you could form that symbol in order to state it more simply without writing that word perpendicular. Right, here's just a summary. So parallel lines have the same slopes. Notation M, slope of line 1 equals the slope of line 2. That's what that notation means. All vertical lines are parallel to each other. Perpendicular lines have negative reciprocal slopes. So the slope of line 1 is equal to the negative of 1 over the slope of line 2. To give you a better example, if the slope of line 1 is a over b, the slope of line 2 is negative b over a. So change the sign and flip. Also, it's good to note that all vertical and horizontal lines are perpendicular to each other. So we're going to use that information in these 4 examples and write equations of lines given the criteria that are described. Number 1, write an equation for a line parallel to y equals 1/3 x plus 8 containing the point 9,5. So in order for me to use the point slope form, I need a point and I need the slope. Now I have a point, 9,5. I don't have the slope, but I have enough information to help me find the slope because I know that the line that I'm writing the equation for should be parallel to this line y equals 1/3 x plus 8. So if I know the slope of this line, I know the slope of a parallel line. So let's take a look at that. Alright, so again I want to be parallel to y equals 1/3 x plus 8. So I want to find the slope of this line. So the slope of this line is 1/3. The slope of the parallel line, so I'm just using the parallel symbol, slope of the parallel line will also be 1/3 because the slopes are the same. So now I could go to my point slope formula, y minus y1 equals m times x minus x1. I have my slope and I have my point. So y minus my y1 is 5 equals m 1/3 times x minus my x1 is 9. Go ahead and distribute that 1/3. Y minus 5 equals 1/3 x minus 3. And then isolate y, add 5 to both sides. Y equals 1/3 x plus 2. So this line is parallel to the given line. Notice their y-intercepts are different, right? This one passes through at positive 8, this one passes through at positive 2. In the second example, we want to write an equation for a line perpendicular to y equals negative 2x plus 1/7 containing the point 5, 0. So I want to be perpendicular to this given line, and I want to pass through this point 5, 0. All right, so the slope of this line is all we need to find the slope of the perpendicular line. The slope of this line is negative 2, so the slope of the perpendicular is the negative reciprocal. Negative in the sense of opposite, right? This one is negative, so the opposite will be positive. And if I think of the reciprocal of 2 over 1, I have 1 over 2. So the slope of the perpendicular line will be 1/2. Now I have my slope and I have a point. I can go to the point slope form. Y minus y1 equals m times x minus x1. Fill in all the pieces. Y minus 0 equals 1/2 times x minus 5. Well, y minus 0 is just y, so I can just now distribute this 1/2 x minus 1/2 times 5 is 5/2. So the equation of the line perpendicular to the given line is y equals 1/2 x minus 5 over 2. And again, do notice that the slopes are still negative reciprocals of one another. Okay, number 3, write an equation for a line perpendicular to y equals 9 passing through the point 4, negative 3. All right, so when we're working with horizontal and vertical lines, it might be helpful for you to kind of visualize what's happening by making a quick sketch. I want to be perpendicular to a horizontal line. So if I'm perpendicular to a horizontal line, the line that I am drawing or writing an equation for is going to be vertical, right? Just to give you a quick sketch of what's going on. Y equals 9 is horizontal, so my sketch is here. So here, that's negative 9. I'm going to be a positive 9 at the top. So this would be my line. Y equals 9, not worrying about a scale or anything like that, just a sketch. And I want to pass through this point 4, negative 3. So 4, positive 4, negative 3 will be somewhere in the fourth quadrant. So let's say it's here. That's totally not to scale, but it doesn't matter. This is just a sketch, right? So we're passing through that point. I want to be perpendicular. So the line that's going to be perpendicular will be a vertical line. Do a different color here. So if I am writing an equation for a vertical line, I don't have a slope, right? The slope is undefined. So I need to just think about what the equation of that vertical line that would pass through this point, what would that be? So we know that the equation of a vertical line is always x equals, and the x-intercept would be the same as any x value for any point on that line. So the x-intercept should be at 4, because remember, this is an equation that says give me all the points that have an x value of 4. So the equation of my line would be x equals 4. So there I'm not using the point slope form because I can't. I don't have a slope. It's undefined. In the last example, we're writing an equation for a line parallel to x equals -1, passing through the point -2, 10. So once again, whenever you're working with vertical and horizontal lines, just draw a sketch to help you to figure it out. Maybe you could avoid some work if you just think about a sketch. I want to be parallel to a vertical line. Well, if I'm parallel to a vertical line, then I'm writing the equation for another vertical line. Let me just draw a sketch of what's happening here. So the given line, x equals -1. So -1, let's say, lives here. And my line x equals -1 is like so. So this is x equals -1. I want another line that's parallel to this, so another vertical line, but I want to pass through this point -2, 10. Now what quadrant is -2, 10 in? So -2 means I go to the left 2 units and then go up to 10. So it'll be somewhere over here. Again, this is not necessarily to scale, but that doesn't matter. It's just a sketch. We're not graphing. All right, so I want to be parallel to this, but passing through this point. So I need to have another vertical line, and that vertical line is going to pass through the x-axis at -2, the same x coordinate as what we have here. So the equation of this line should be x equals -2. And you would do something similar if the line that you were writing an equation for was horizontal. If we wanted to write an equation for a line horizontal to that, we draw a sketch in the other way, but it would be y equals, and then you would pick the y coordinate of the point that you want to pass through. So it's very similar. With a horizontal line, you could also use the point slope form because y equals the number of horizontal lines have a slope of 0, so you could put in 0 as the slope there. All right, that concludes this video and our talk on writing equations of lines.